Next, I would like to let you know some key points when using weighing paper instead of glass samplers for sampling. In some specific cases, when the sample is very hygroscopic, for example, the measured values may be affected by the water that is attached to the surface of the weighing paper. The table in the slide illustrates the measured values of choline chloride. The upper line shows the result with weighing paper, and the lower line shows the result with a glass sampler. The average value with weighing paper is 1%, and it is more than twice as high as the one with a glass sampler. This is a typical example in which water from the weighing paper affects the measured values. You should therefore be very careful in handling samples when you plan to measure hygroscopic samples. Let's turn now to treatment of viscous samples, such as paste or starch syrup. It is rather difficult to handle such samples and pour them through the injection port, and thus I will show you some ways using the video. To begin with, there is a spoon, like an ear pick, attached to a sealing plug. First, weigh the sample bottle, then scoop up the sample with the spoon part. Quickly remove the stopper, insert the sample through the stopper hole and dissolve it in the cell. You can calculate the sample weight by weighing the sample bottle after the sampling. That is to say, the sample weight is the difference between the weights before and after the sampling. This is a typical example of using a spoon attached with a sealing plug. This video shows the way to use aluminum foil with Ca200 and the water vaporizer Va200. You can stick the viscous sample on aluminum foil and measure the weight. Fold the aluminum foil and quickly drop it into the sample boat. Then start the vaporizer. This is another way to measure viscous samples. Optional apparatus and devices are listed in this slide. The water vaporizer, Va200, is the most widely used type of vaporizer and can heat the sample up to 300 degrees centigrade. We also provide other water vaporizers. One is designed for vials, one for automatically sampling vials, one designed specifically for heating oils, and another for high-temperature use for which you can reach 1,000 degrees centigrade. We also provide a vaporizer of liquefied gases and an option to run potentiometric titrations. We also have PC software which complies with US FDA 21 CFR Part 11. Now I will introduce the water vaporizer Va200 in more detail. This is one of the most commonly used water vaporizers, where the samples are placed and heated in sample boats. After placing the sample into the sample boat, the boat automatically moves into the heating unit. The vaporized water from the heated sample is carried with nitrogen gas into the titration cell and is titrated automatically. Thus, nitrogen is needed as a carrier gas to run this unit. In this slide are illustrated the actual measured values of plastic pellets with colorimetric titration and a water vaporizer. This system is widely used for PET, nylon 66, and other plastic pellets. When using a vaporizer, it is important to use the optimal heating temperature for each type of sample. Next, I would like to explain two ways to investigate and determine the proper heating temperature. One is to refer to the measuring examples tabulated in the technical manual, and the other is to use the step-up function of the water vaporizer. The step-up function means, for instance, that the heating temperature is raised from 120 degrees centigrade to 220 degrees, step by step, in 20-degree intervals. The amount of moisture coming out at each interval is measured separately. The proper heating temperature can be determined based on the acquired data. I will explain the step-up function in more detail by illustrating two examples in the next slide. The results of the step-up function with Va200 are illustrated in this chart, where the amounts of water at each temperature are shown as moisture in bar shapes. In case 1, the moisture decreases gradually as the heating temperature rises above 140 degrees centigrade, so the proper heating temperature should be 200 to 220 degrees centigrade. In case 2, on the other hand, the moisture decreases as the heating temperature rises until the middle of the operation, 180 degrees centigrade, and increases again after that. We sometimes encounter such results in resin samples. The increase after 180 degrees is most likely caused by the pyrolysis and water generation of the sample, or by formation of reactive gases that affect the Karl Fischer reaction. The proper heating temperature for this sample should be around 180 degrees centigrade in order to suppress side reactions other than the water vaporization. In the following 3 slides, I will introduce the water vaporizers VA230 and VA236S, both designed for sampling vials. Since the samples are placed inside vials, these apparatus have 2 advantages. One is that neither the heating tube nor the sample boat become dirty, and the other is that they are suitable for measuring hygroscopic samples because it is easy to handle such samples. It is highly recommended to collect and weigh the sample in a dry atmosphere to suppress the effect of moisture in the air. Apart from sample vials, you need to prepare an empty vial for blank measurement. This is necessary because even an empty vial contains some moisture, and the result of measuring a sample vial is the total of sample moisture and blank moisture. The correct result for the sample can be obtained by measuring the total moisture in a sample bottle and subtracting the blank value of an empty vial. If the moisture content of the sample is so high that the effect of blank moisture is irrelevant, the blank measurement can be skipped, but in most cases it is recommended to measure and subtract the blank value. I have previously shown you an example in which opening the sample injection port for 10 seconds would result in 200 micrograms of moisture. You can assume that a vial handled in a standard environment would also contain about 200 micrograms of moisture. This will, of course, change depending on the humidity of the ambient air. This slide shows VA230 at the upper right side and VS236S at the lower left. The VA230 is operated manually. The black handle on the top is used to pierce 2 needles through the vial septum. One of the needles flows carrier gas nitrogen into the vial, and the other needle leads the sample moisture into the titration cell. The VA236S will automate the measuring sequence of VA230. Up to 33 sample vials can be set on the turntable, and all of them can be measured automatically, one after another. So, if you have many samples to measure, the VA236S would be a suitable option. The following are actual data of various kinds of samples measured with VA230 or VA236S. The solid water standard and plastics are in the upper table. As a further option, oils can also be analyzed. Some results of machine oils, biodiesel fuels or BDF, and insulating oils are listed in the lower table. Lubricants, such as engine oils, are liquid, and thus they seem able to be analyzed by normal direct injection of samples. However, most lubricants contain several additives that are oxidative or reductive and could interfere with the Karl Fischer reaction. Therefore, it is recommended to use the water vaporizer for lubricants, VA210, for such purposes. I will show you some examples in the next slide.